Okay, good morning, everyone. Let's get started. Today we have a short lecture, which is on wood. Okay, but before we do that, we have several things to discuss. The first thing is about assignment. Okay, we have several assignments which will be due soon, and some students get confused. I think part of the reason is because I didn't make it very clearly, so sorry about that. Okay, so we have, first of all, the lab number 4 and 5. So lab number 4 and 5 is due on, let me see, the due date. For Monday groups, is due on November 30th. Okay, so again, this is group report. So every group only submit one report, which is combining lab number 4, fresh property of concrete, and lab number 5, which is hardened property of concrete. Okay. Lab number 5 is this week. So for Wednesday group, I'm gonna see you this afternoon. Okay, again, one group report. I should emphasize that this is group effort. So everybody need to contribute. Okay, so you cannot, do not respond to emails. You should, discuss with your team members, assign the tasks, okay, work together on the assignment. So as a civil engineer, future civil engineer, you will work together as groups. Okay, so you cannot do a big project by yourself. So you have to be able to work with everybody. Okay, so work with your team member. Okay. So that's lab number 4 and 5. Some students get confused as the concrete mix design. So we have normal concrete mix design, which is our quiz number 2. So we did that in class, also as a team. Okay. So you should attach that normal concrete mix design to your lab number 4 and 5. So basically, in the previous semester, you use this normal concrete mix design to cast your concrete in lab number 4 and test the strength in lab number 5. Okay, so you use the lab mix design in your lab report. Okay, and we also have a high strength concrete mix design. So that is another assignment, okay, which, let me see, according to the schedule, which is due today. Okay, so if you get confused, that is okay, but please submit your high strength concrete mix design as soon as possible. Also, as a group, this is a group effort. Okay, so for high strength concrete mix design, you do not need to provide the steps for the design. Just give me how much water, cement, aggregate, and any type of added mixtures in your concrete. Okay. All right. Hope I make it more clear. Any questions about this assignment? Okay, one last thing, we have a term paper. Okay, for term paper, we have the abstract, which is due today, November 18th. So if you haven't done that already, so please submit your group abstract for your term paper and presentation. Okay, so half page is okay. For the title, please be specific. For this term paper, which should be around 15 to 20 pages, you should be focused enough. Do not make the title too broad. And also make sure you do your literature research, basically journal papers about the focus you work on. Okay, at least I will see 10 journal papers for your references. Okay. All right, the presentation is in 2 weeks, November 30th, December 2nd, and December 7th, depending on your groups. Okay, so again, this is group effort. Make sure you work with your group, okay, for everything. All right, this is our last assignment, term paper, and presentation. Okay, so today we're gonna talk about lecture number 20, which is wood. Okay. It's gonna take about 20 minutes to finish lecture. And after that, if we have more time, we're gonna talk about our midterm. Okay, so we haven't finished grading the midterm yet, but we can talk about the answers. Okay. So lecture number 20, wood. All right. All right, for wood, everybody is pretty much familiar with wood. Wood can be used as structure support, or we can use wood to make floor, roof, and also single family houses and house with a few levels, typically below 5-story buildings. Okay, small buildings. Okay. So here shows a cross section of wood structures. So one special property of wood is anisotropic materials, which means in different directions. For wood, we have longitudinal directions, which is along the wood cell directions, or we have radial directions, which is perpendicular to the diameter, parallel to diameter. And then we have these tangential directions, which is perpendicular to the diameter. Okay, so the property in these three directions are very different. All right, the reason for that is because the wood cell is tubular structures. The wood cell is along the longitudinal directions. Okay, so parallel to the tree's trunk. So as a result of that, the nature of wood in these three directions are quite different. So does physical, mechanical properties, such as shrinkage, stiffness, and also strength. Okay, remember that. For concrete, concrete is almost homogeneous in all the directions. So wood is not. We also has moisture content for wood. Okay, remember for concrete, we have moisture content for sand and coarse aggregate. And we can calculate absorption capacity, the total moisture, and also moisture content for aggregate. So for wood, the moisture content is defined as the total weight of water. So we put a piece of wood in oven and we dry it. Depending on the difference of the weight, we can calculate the weight of water. So that divided by oven dry weight of the wood is the moisture content of the wood. Okay, and moisture content will affect the weight, obviously, and also shrinkage and the strength of wood. Okay. The moisture content including two types of water. The first one is called bond water. The bond water is adsorbed within the wood cell. Okay. And change in the bond water will cause shrinkage, swelling. If the bond water increase, the wood will swell. If the bond water reduce, the wood will shrink. and also changing mechanical properties. Okay. So beyond the bound water, we have the so-called free water, which is water in the cavity between the cells. Change in free water does not have big effects on shrinkage, sweating, and other mechanical property of wood. Okay, so this is similar to the moisture in aggregate in concrete. We have surface moisture, and we also have moisture inside the permeable pores in aggregate. Okay. So again, the moisture content, we have bound water and also free water. Okay. Another definition for the moisture content of wood is the so-called fiber saturation point. Okay, depending on the type of wood, the saturation fiber saturation point, or FSP, is between 20 to 30%. FSP is defined as the level of saturation at which the cell wall are totally saturated with bound water, but there's no free water existing in cell cavities. Okay, to help you remember that this is kind of similar to SSD condition of aggregate in concrete. Okay, so SSD is saturated surface dry condition. For FSP is all the wood cell is saturated with bound water, but there's no free water. Okay. For green wood, the moisture content is larger than FSP. The reason we care about FSP is because the addition or removal of moisture below the fiber saturation point has a big effect in physical and mechanical property of wood, because below FSP, we have a change in the bound water. Okay. Above FSP, we have a change in free water. And remember, in the previous slides, we know changing in free water has no big effect on mechanical and physical property of wood. Okay. Okay, so remember that. And here is a small calculation example for the shrinkage and the sweating of wood. And here shows shrinkage and sweating of wood in the three directions: tangential, radial, and also longitudinal. Okay, and we can see beyond the fiber saturation point, there's no shrinkage or sweating. Okay. So let's see, for the wood, the fiber saturation point is 27%. Okay. And the initial length of the wood is 400 millimeter. And the wood will shrink 0.8% in the longitudinal direction from FSP, which is 27%, to oven dry, which is 0% moisture. Okay. So the question asks for how much the wood will change in length when moisture content change from 14% to 30%. Okay, so which is from here to 30%. So 30% is beyond FSP, which is 27%. So between 27 to 30%, we have change in free water, and that does not affect the shrinkage at all. So what we do is we answer there's no change from 30 to 27%, but below 30%, we can do linear interpolation. Okay, because the change in length is linear below 27%. So based on that, the percent swell will be based on that. So 0.8% total between 0 to 27%. So for 27 to 14%, we have this much. Okay, so around 0.35% which is swelling because the moisture content increased from 14 to 30%. So increase in moisture content, the wood will swell. Okay. So this is translate to millimeter is plus 1.54 millimeter. Okay. All right, so last couple of slides about wood, we talk about grit and also other property of wood. So the lumber is graded based on number of flaws, which will affect strength, durability, and workability. Okay. So for hardened wood, the grade is based on amount of usable lumber on each piece of standard length lumber. We have number 2, number 3, number 1, number 2, and number 3, A and B. Okay. For softwood grade, it is based on visual inspection of the wood. Okay. So that is also different from concrete. For concrete, the grade is based on the strength and other performance. Okay. For physical property, the density of wood is around 300 to 700 kilogram per cubic meter. Okay. For concrete, it is around 2,400 kilogram per cubic meter of concrete. So much higher density for concrete. Thermal conductivity of wood is pretty low, much lower compared to concrete. And that is depending on grain orientation. Okay. For longitudinal direction, thermal conductivity is higher than the other direction. Increased moisture content of wood will also increase thermal conductivity. Increased specific gravity will also increase that, and so does extractive content and knots and other irregularities. Okay. So the typical value is around 0.009 to 0.0014 millimeter per meter per degree Celsius. And when heated, due to thermal expansion, the wood will expand. But due to moisture loss, the wood will shrink. So the net effect when we heat the wood is shrinkage. For electrical resistivity, it will decrease a lot for each % change in moisture content. And when wood reach the fiber saturation point, we just take the resistivity of water alone. Okay. The modulus of elasticity, the E value, will also depending on the direction we talk about. So does the strength. Okay. The tensile strength in longitudinal direction is 20 times higher than the tensile strength in radial direction. Okay, we have a huge difference in strength depending on orientation of wood. Okay. And typically, the tensile strength is larger compared with compressive strength of wood, okay, especially in longitudinal direction. And wood will have more creep compared with concrete. So longer the load duration, the higher the creep. So we should reduce the maximum load the wood can support for longer duration. And the design value of the wood is for 10 years load duration. And for lifetime structure, we take that value to 90%. So 90% of design value for continuous load of wood structure. Okay. So that's a short lecture about wood structure. Okay. So next, let's talk about our midterm. Okay, we have around 30 minutes left in the midterm. Sorry, in this class. So let's talk about the midterm question. Right. So we are still trying to grade the midterm. Can you see the midterm question? Right.
Yes.
Okay, great. Thank you. So here is the midterm. Question number 1. Talk about particle size. So the particle size of ordinary Portland cement, which is around 10 to 20 micrometer. So it's how many times the size of typical flash? Okay. But typical flash has a similar size as Portland cement, also around 10 to 20 micrometer. Okay. So the right answer should be A, 1, same size. Okay. The second question is, which one of the following is fundamental measurement of consistency of fresh concrete? Okay, so consistency is defined as how easy the concrete can flow, and the measurement for consistency is the slump test. So the right answer is A. Okay. All right. Question number 3. Which state best describes as the state of average? So that question is easy. So answer is A. So all pores are filled with water, but there's no film of water on the surface. So A is the right answer. Question number 4. Resistance to sulfur attack in concrete can be achieved by decreasing the proportion of which compound in Portland cement? Okay, so sulfur attack is caused by formation of ethylene, right, which is AFT, all right? And based on the chemical reaction of sulfur attack, we know if we reduce the amount of C3A, okay, we will reduce the potential for ethylene formation after concrete hardens. Okay. So the right answer is A. It's not E because if we increase the amount of gypsum, it will transform all C3A into ethylene. Okay, so gypsum will have to reduce sulfur attack. So the right answer is A, C3A. So question number 5, which is the single most important parameter that affect the durability of concrete to physical and chemical attacks? So I put this question in one of the questions in midterm because this is a very important concept. Okay, so I emphasized several times for durability, permeability is the most important factor controlling the concrete durability. The reason for that is for all the physical and chemical attacks, if we can control the water in and out of the concrete, it will reduce the chemical and physical attacks because all of the attacks will involve the movement of water inside and outside of concrete. So permeability will control the movement of water. So it is the most important parameter. So it is not the strength. Okay? It's not the toughness. It is not water cement ratio. So C is the right answer. Question number 6. Class C flash differ from class F flash. Okay, so that information is from our class notes, lecture notes. So if the calcium oxide content is more than 10%, the flash is classified as class C. Less than 10% is class F. Okay, so B is the right answer. For the next multiple choice questions, 7 to 12, we could have more than one correct answer. Okay, so question number 7. So in following descriptions, which one cannot help to enhance the strength of concrete? So reduce the water cement ratio. It can enhance the strength. B, replace partial of the cement with silica film. Okay, and it can also enhance the strength. Use air entraining agent. So entrain air bubbles in concrete will reduce the strength. So that cannot help to enhance the strength. So C is right. D, prevent moisture loss during curing. So the longer the moisture curing, we have higher degree of hydration, we have more hydration product, so we have higher strength. So D is not right. Questions, right? Okay. So D is not right. E, use larger coarse aggregate. Okay. If we increase the size of coarse aggregate, will increase the stress concentration along the ITZ. As a result, the strength will be lower. That's why for high strength concrete mix design, we use smaller coarse aggregate. So use larger coarse aggregate cannot help to enhance the strength. So the right answer is C and E. Question number 8. To generate higher hydration heat, which chemical compound should be increased? All right. So the ranking for hydration heat is C3A more than C3S, more than C4AF, and more than C2S. See, so the top two is C3A and C3S. So to generate more hydration heat, we should increase C3A and C3S. Okay, so that's the reason why for type 4 cement, we should reduce C3A and C3S. Okay, type 4 cement is low heat cement. Question number 9, which method cannot help accelerate strength gaining speed of concrete? Okay. Use accelerator. Of course, we can use steam curing. More moisture, higher temperature will accelerate the chemical reaction, the hydration. So that will accelerate strength gaining speed. Type 4 cement, that's low heat cement. So that is right. And flash. So flash is one type of pozzolanic materials. And we know pozzolanic reaction will slow down the hydration. So D is right. And so does E. Adding slag, we also introduce pozzolanic reaction, so that will slow down the hydration. The right answer is C, D, and E. Question number 10. Which of the following method can increase ITZ? Okay, so in the lecture of aggregate, we talk about ITZ and how we can improve the ITZ and also strength of concrete. So let's look at A, increase the water cement ratio. So that does not help. That will reduce the bonding between paste and aggregate. Use silica film. That will enhance the ITZ. Okay, because we use silica film in high strength concrete. One reason for that is silica film is a very reactive pozzolanic materials. So that will transfer calcium hydroxide into CSH in the ITZ. So that's the reason it can increase the bonding. Okay. Another reason for silica film to enhance the ITZ is because the particle size of silica film is very small. That will enhance the packing density of solid in the cement paste. So use silica film definitely will improve the ITZ. And that's the reason we put silica film in our high strength concrete. Okay. So always use silica film in high strength concrete. C, use aggregate with rough surface texture. Okay, if we make the surface texture of aggregate rough, that will of course increase the bonding, the ITZ. Okay, so C is correct. Okay. Use larger aggregate. So if we increase the size of aggregate, we're gonna increase the potential for bleeding and segregation. That will reduce the bonding, reduce the ITZ strength. Use retarder. It will affect the hydration speed, but it will not have a big effect on the strength of ITZ. So the right answer is B and C. Okay. If we only mention one of them, for example, if you only mention B, you will get half credit. But if you have one of the wrong answer, you will get 0 credit. Okay. Next question, 11. The detrimental effect of ASR could be reduced by A, lower alkali cement. Okay, reduced alkali content in cement will reduce alkali, so reduce the potential for alkali-acidic reaction. So A is right. Use pozzolanic materials. It will definitely reduce ASR for many reasons. So one of the reasons is it will reduce amount of alkali. Okay. Another reason is it will reduce the concrete permeability. Okay. So we talk about that when we discuss ASR. So B is also right. Use air entraining agent. Air entrainer will generate tiny air bubbles in concrete. So when we have alkali silica gel generated in concrete, we have expansion in volume. Okay. The reason we have cracking due to ASR because the gel is expanded. If we have air bubbles in concrete, and that will potentially reduce the stress generated by this gel. So air entraining agent can reduce the potential for ASR. If you use non-reactive aggregate, we're gonna reduce the silica, so that will also reduce the potential for ASR. Reduce the moisture content in concrete. We also reduce ASR because without moisture, the gel cannot expand. Only with moisture, gel can expand. So E is also correct. Okay. Question number 12. Corrosion of reinforcement could be reduced by A, galvanize the rebar. So this is right. So by galvanize the rebar, the thin layer of zinc. Okay, so typically, what is galvanize? Galvanize is we apply a thin layers of zinc on the surface of rebar. So in that case, zinc will serve as anode, and all the steel will serve as cathode. So steel will be protected, and the zinc layer will be sacrificed. So galvanize the bar will help the corrosion. B, increase the pH level of concrete. So increase the pH level will help generate the protective film on the surface of rebar. So higher pH level, the better. On the other hand, increased concentration of chloride in concrete will destroy this protective film on the surface of rebar. So reduced chloride exposure can also reduce corrosion of reinforcement. So C is also right. D, increase the thickness of concrete cover. So increase the concrete cover, we increase the barrier between the rebar and the air. Okay. Let's say this is the concrete, and the bar is here. And the concrete cover is the concrete 1 or 2 inch typically between air and rebar. Okay, so because concrete has high pH level, and concrete can also reduce the penetration of air and water from the air to touch reinforcement. So increase the thickness of concrete cover definitely will reduce the potential for corrosion. Reduce the pH level, that will not help. So increase the pH level, reduce the corrosion. So the right answer is A, B, C, and D. All right. The next question. The first few hours after cement and water mix are called dormant period or induction period. Okay. So at end of dormant period, the concrete will set. So you mentioned that the series explain the dormant period is called nucleation control or nucleation dissolution series. Okay, so what is nucleation control series? Okay, so we talked about that a couple of times during class. Let's say this is cement particles mixed with water. Okay, so the hydration heat, something like this. We have 5 different stage. Okay, stage 1, we have fast dissolution, and stage 2 is called dormant period. Okay, and stage 3 is hydration will accelerate. Stage 4, the rate will slow down, and then stage 5 is called stable stage or diffusion control stage. The reason for the second stage is very, we call that dormant period. And dormant period is very important because during that period of time, we can transport the concrete to the job site and finish the concrete. From the chemical reaction point of view, why we have stage 2 is because we do not have hydration product generated until the concentration of calcium and hydroxide ions achieve a certain so-called threshold concentration. So the cement particles will slowly release calcium and hydroxide ions into the water, into the porous ocean. Okay. There's not much hydration product generated until the threshold concentration is reached. After that, we have hydration product generated. So at end of stage 2, it is initial set, because at that time, we have more hydration product generated. Okay, and the final set time is here. So if you mention something about the threshold concentration, you will have the full credit. Okay. So one knows about short answer and calculation questions in the exam is if you do not know the exact answer, do not leave anything blank. You write something you know, so I will give you partial credit. So if you leave a blank, I cannot give you partial credit. Okay, so just try your best to write something on that. Okay. B, what's the effect of adding calcium salt? Okay, when we introduce calcium salt in the system, we manually increase the concentration of calcium ions. So the time to achieve that threshold concentration is shortened. So we manually change when the concrete will set. We have initial set time. So introduce calcium salt will shorten the dormant period. So the setting time will be reduced. Okay. Question number 14. Type 4 cement, which is low heat cement, is rarely produced in the US because flash and slag is readily available. Why? Okay, so this question is very simple because, we talk about pozzolanic reaction. Okay, and pozzolanic reaction is calcium hydroxide, which is one of the hydration product of cement. Flash and slag will provide silica oxide, S, plus water, it will generate CSH. Okay, and this reaction is slow. Okay, when we replace part of cement with flash and slag, we introduce pozzolanic reaction in the system, and because it is slow, it will reduce the hydration heat. So we have the same effect as type 4 cement, low heat cement. Okay, so if you mention about pozzolanic reaction, which is slower compared with hydration of cement, you will get full credit. All right, so we have about 5 minutes. The next question is about describe moisture content, moisture state in the sand and coarse aggregate, and adjust moisture content. So the question itself is, you should definitely be able to answer that questions. And for sure, we'll have similar questions in our final exam. So if you do not know how to calculate the moisture content and adjust the moisture content for sand and coarse aggregate. So make sure you understand that. Okay, we don't have enough time today, but we're gonna stop at 9:20 anyway. So the first part of question: what is the field moisture state of fine and coarse aggregate? So you need to do some calculation for that. Okay, so based on absorption capacity and also the oven dry weight as well as the stockpile weight. So for example, for sand, you can calculate the WSSD, which is saturation surface dry weight. Okay. So based on the equation from the 1 plus slice in aggregate, it is equal to 1 plus absorption capacity times oven dry weight. Okay. And AC for sand is 1.5%. Okay. So that is 0.015. W oven dry is given, so 973 gram. So WSSD we calculate is 987.6 gram. Okay. All right. And based on that, we can calculate the moisture content, which is equal to W stock minus WSSD over WSSD. Okay. So W stock is given 1,000. WSSD is just calculated 987.6. So the moisture content for sand is 1.26%. Okay. So what does moisture content mean? So moisture content means how much difference the real moisture content of the aggregate is different from saturated surface dry condition. If moisture content is positive, larger than 0, then the moisture condition will be wet. Okay. The moisture content could be negative. In that case, that means the moisture content is negative. The moisture condition will be air dry condition. Okay, so that is for sand. You can do similar things for coarse aggregate. Next part, what is the water cement ratio of a mixture? So that is very simple. Okay, the reason we do the moisture adjustment is exactly to make sure the water to cement ratio does not change based on moisture condition of aggregate. So the water cement ratio will be exactly as amount of water divided by amount of cement in our mix design. Okay, so that's 0.6. Okay, and let me just use 1 more minute to do the moisture adjustment. Okay, so to do the moisture adjustment, we should use the moisture content we just calculated. Okay, for example, for sand, the moisture content is 1.26%. Okay, so we use 1,400 times 1.26%. So that is equal to 17.64 pounds. Okay, because the sand is wet. Okay, so we should use more sand compared with SSD sand. So the real amount of sand we use is 1400 plus 17.64 is 1417.64. And accordingly, for mixing water, we should minus 17 from white form. Okay, so we should do the same thing for gravel. Yeah, let's stop here today. Okay.